This is part 3 of the Unit 4 lab. And so what we did was we put together the aluminum sulfate and the potassium chromate. And we got that green with the dark yellow again. And now we'll do the aluminum sulfate with the silver nitrate. And does that one react? Nope. All right, so we have one more left to do, and that's our potassium chromate with the silver nitrate. And did we have a reaction? Yep, we did. And what would you say about the liquid and the precipitate? I would say a light brown liquid and a dark brown precipitate. All right, and we had that before. All right, now what I'm going to show you is, let's see if I can find the paper I'm looking for. Here we go. I made a list of all the ones that reacted. So if you notice, these all have a white tan, and then these have yellow or the dark brown, the green. Okay, so I separated them into two different categories. So let's look at this one first. The ones that formed a white liquid with a tan precipitate. What element do you think is causing this white liquid with the tan precipitate? So in other words, we're saying, okay, this is one reaction, this is another reaction. What do they have in common? Well, they both have barium nitrate, so that's the same. Do they both have the Na? Nope. This one has aluminum. Does that one have aluminum? Nope. Okay, now do they each have SO4? Yes, they do. Okay, so far that's a commonality. So that's the same for both. So let's look at the next reaction. All right, does this reaction have a Ba in it? Yep, all right. Does it have an NO3? Oh, that one doesn't have an NO3, which means NO3 is not the answer. It's not the same thing that is the same in all of them. Does this one have a sulfate, an SO4? Oh, yep, it does. All right, but again, not the Na, not the Cl. So far we're down to they all either have Va or SO4. So which one? Which one is it? Which one is the one that's causing the white and the tan? Well, if we look here, it has a Ba. Does it have an SO4? Nope. So right there, it tells us that Ba, barium, is an element that causes the white reaction. So it's kind of cool how you can figure that part out. All right, so let's look down here. Now what do we see? All right, so we have the mustard yellow. So we have magnesium with nitrate. I'm going to get rid of all the extra stuff. And all right, we got magnesium with nitrate, same. And we have sodium. Does this one have sodium? Nope, it has potassium. All right, so our answer for what's causing the yellow has to be one of these. Let's look at the next one. Sodium. Is sodium up here in our choices? Nope. Is chromate, CrO4? Yep, so we got to hang on to that. And now we're checking for the magnesium and the nitrate. So nope to aluminum. There's no magnesium, no nitrate. So that tells us that chromate, this polyatomic ion, which is CrO4, is what gives us the yellow. So it's kind of cool how we can look through that then. All right. Let me go ahead now and we will look at the next set of questions. All right, so it says define double displacement reaction. So the double displacement reaction is what we did up here. We took these chemicals and we added them together. There we go. and we added these chemicals together. And when we did, we created a precipitate. We created something new. And the reason that that happened is because they did what? Did they trade partners or did they stay the same? Well, we had a chemical reaction, so they changed partners. So we started out with them being the two separate aqueous ionic compounds, or in other words, the ionic compounds which have a metal and a nonmetal or a polyatomic ion, and they were dissolved in water. And now this aluminum right here says, all right, I'm going to partner up with chromate. And what do you think the other one's going to be? What's the other chemical going to be? Well, it's going to be the potassium. And who's it going to partner up with? The SO4. Yeah, so they swapped partners. Now, if you notice, you always write the positive one first. So if it was first in this compound, it has to be first in that compound too. And that's a double displacement reaction. So it's a chemical reaction where they change partners. They change who they're combined with. All right, positive ions are called what? Is it a cation or an anion? It's a cation. And a negative ion is an anion. When a double displacement reaction occurs and a new substance is created, which one do you write first? You always write the cation, which is positive first. Positive charges are blank to negative charges. Are they attracted or repelled? They're attracted. Therefore, when you make a chemical, one must have a positive charge and the other must have what kind of charge? A negative charge. All right, I want you to look at your periodic table and group 1 with hydrogen and lithium and sodium. What charge are all of those ions going to have? +1. They're going to lose their valence electron. What about group 2A? What's their charge? +2. What about group 3? +3. Now group 4 is going to share, so they're not going to make an ion. What about group 5? They want to gain electrons. They're going to gain 3, so their charge is -3. Group 6 wants to gain how many? 2 for a full outer shell to be stable. And when it gains 2 electrons, what's the charge going to be? -2. Group 7A has how many valence electrons? 7. How many total does it want? 8. So what's it going to do? Gain 1 electron. And what's the charge going to be? -1. And group 8A does not react. Why not? They already have a full outer shell and are stable. That's why we call them the noble gases. They're not going to react. They're already stable. They're rich. They're not going to deal with those peasant atoms over there. All right. So I switched screens because what we're going to do for the next part is talk about how we predict what the products are of our chemical equation. So we started out with lithium and sulfur in this case, Li2S. Well, you know what? Let's name this. So, do you remember what I said the rules are for naming? So, you write the name of the first element, and then write the name of the second element, but what do? Change the N to end with I-D-E. All right, so what's Li? Li stands for lithium. And what's S? S is sulfur, but instead of sulfur, I want to change the ending to what? Ide. So it's going to be sulfide, lithium sulfide. All right, and then it's plus MgBr2. So what element is Mg? Magnesium. And what element is Br? Bromine, but instead of bromine, it's going to be what? Bromide. So that ionic compound is called magnesium bromide. Not too bad. All right, so now let's go ahead and predict the products. We're going to say who's going to pair up with who. Well, it's kind of like FOIL in math class. Have you done FOIL? First, outside, inside, last? Well, it's just the OI part of FOIL. So our outside ones are going to go together, and our inside ones are going to go together to make the new compounds because they're switching partners. So the Li, as I just said, is going to go with who? It's going to go with the bromine. But here's where it gets a little bit tricky. We don't move these 2's. We just move the element, and then I look and I say lithium's in group 1. So what is the charge of lithium? The charge of lithium is +1. And what's the charge of bromine? Oh, bromine's over here in group 7. So it wants to gain 1 electron. So its charge is -1. And then we do what looks like cross multiplying. We put that number down there. And we put this number down here. And when we do that, what do we get? We get Li, lithium, with a little 1. And we get Br with a little 1. Do we need to write the 1's? No, we don't, but you can. And what would we name this? Well, what's Li stand for? Lithium. And Br is what? Bromine. But what do we have to do? Change the ending to ide, lithium bromide. All right, now let's look at our other compound that we're going to make. So the other compound, we're going to put together the sulfur and the magnesium. All right, magnesium is right here in group 2. So what's the charge? It's going to have a +2 charge. And sulfur is over here in group 6. So its charge is -2. Now, the reason I did it over here this time is because which one do we have to write first? We have to write the magnesium first. Ladies first. Okay, you have to put the positive one first. So we'll go ahead and put our magnesium first. And then we'll go ahead and put our sulfur second. And we're going to do the same thing that we did with the other compound. We're going to do what looks like cross multiplying. I'm going to put that number down here. And we're going to put this number down here. And what does that give us as our final product? Well, that gives us magnesium. And our magnesium is going to have a 2 there, and a sulfur, and our sulfur is going to have a 2 there. But you know what? We can reduce. Since they're both 2's, we could just write it as MgS. We could reduce it. And what would the name of that compound be? Well, what does Mg stand for? Mg stands for magnesium. And what does S stand for? Sulfur, but change the ending to ide, magnesium sulfide. So again, what we did, we took lithium sulfide and magnesium bromide. They switched partners because it's a double displacement reaction. The lithium and bromine went together, but we don't bring over the subscripts. We have to start over with their charges and cross them down to make our new compound, lithium bromide. We brought over the sulfur and the magnesium, but ladies first, the positive one's always first. We do what looks like cross multiplying. We brought down our subscripts, and then in this case, we reduced, and then we named it.